Right, Bismillahirrahmanirrahim. Assalamualaikum. So today we will continue our lecture on chapter number 3, which is Introduction to Probability. Last class we already looked at counting theory, right? We already know how to do what is a permutation method, permutation rule, combination rule, and there are basically we already look at into 9 theorems, right? And I hope you understand how to do a counting rule, right? So before we go for introduction to probability, let's review some set theory, right? So set is a group of object with a well-defined criterion of membership lah. So a group of object with a well-defined criterion of or membership. So a set is a notation for a set is in capital letter, either in capital A, capital B, C, D until Z lah, right? But the reserved letter alphabet is S, which is this one is defined as a sample space, right? So set, let's say A, this is set A, let's say kita letak A dekat sini lah. A is equal to, it can be either start with a curly bracket or just a bracket lah, either one, right? So this is what we call a set A. So set mesti ada member, a group of object with a well-defined membership lah. So in this case, we don't have any membership lah. So set A equal to empty value lah, empty member means this is a empty set or null set, right? So set A can if they have a member, let's say A, we start with a curly bracket 1, 2, 3, 4, right? So ini dipanggil element. This is what we call as element of a set, right? So X is an element of S, right? So then we can write X is an element of S. Maksudnya kalau dekat example this one, let's say 2 is the element of A, so 2 is an element of A. So this is how we write the notation of set theory lah. This is just a review, right, before we enter introduction to probability, right? So I hope you already learned this method previous subject lah in mathematics, right? So let's look at A, this one, A dekat sini. Right, this is what we call as empty set because there are no element in this set. So empty set also, the notation of empty set can be write as this one with a phi symbol. This is what we call as empty set lah, phi symbol, right? Right. So let's look at subset. So subset, a set S is a subset of set A if every member in S, every member of S is a member of A. Means that let's say you roll a die, right? Roll a die. So let's say all possible outcome in a die is 1, 2, 3, 4, 5, and 6, right? So before I forgot, so as I mentioned, sample space means that all possible outcome in one experiment. If you toss a coin, so all possible outcome in a coin is head or tail kan? So head and tail saja ada dua. So if you roll a die, all possible outcome in rolling a die is 1, 2, 3, 4, 5, 6. Boleh? So if you already kita dah belajar counting rule kan? Let's say kita ada dua eksperimen, right? Dua objek. So satu objek can be done first step can be done in three ways. Second step can be done in two ways. So how many possible outcome? There are 3 multiplied with 2, which is 6. So we already know sample space have 6 possible outcome. So let's say we have a sample space for rolling a die. Let's say we roll a die twice, right? So we got 1 and 4, right? Which is the head apa yang facing up tu kan, number facing up tu 1 and 4. So 1 is a member of A juga. 1 is in A tapi is also in S. 4 pun ada dalam S. So means that we can say A is a subset. Kejap. This is A is a subset. So kita letak macam ni. This is a symbol of subset of S. Right? So ni terbalik lah. Oh yeah, betul-betul. Yeah, correct. So this is a symbol of subset. Maksudnya dia C with the garisan dekat bawah ni lah. Right? So A is a subset of S. Sebab A, element in A, member of A ada dalam S. Right? Sama juga contoh yang bawah ni dia terbalik lah. Macam confusing sikit. Right? So jangan tengok contoh ni. A bit confusing. Cancel this example. Right? Basically it's the same concept lah. But a bit confusing with my first example ni. Right? So let's look at universal set. Universal set is a set contain all object that could conceivably be interest of in a particular context lah. Means it's the same as sample space, but sample space in one experiment. Let's say you do several experiment, you have a universal set, right? So let's look at a union. So union is a set. Union set is when two set S and T are the set of all element that belongs to S or T or both. Maksudnya, we combine element in set A and set B to become a union of A and B. So the notation of union set is U. Nampak sini I highlight. So U is the notation for union. So let's say I have set A. Let's say ada S is rolling a die 1, 2, 3, 4, 5, 6. So this is element all possible outcome in rolling one die. So let's say A, Abu, rolled a die twice. So dia dapat 1 and 4. And then let's say B, rolling a die 3 times. So dia dapat 2, 3 and 5. So if you want to find A union B, means that we will add element in A and element in B to become A union B. So 1, 2, 3, 4 and 5. So kita tambah saja. Right? So the axiom of union set, A union B is also equal to B union A. So this is very important. You need to remember. A union null set means null set. A tambah kosong sama dengan A jugalah. A tambah A equal to A. So A union A is also equal to A. A union sample space. A union with the sample space. So it should be the sample space. Right? Dia tak ada repeated object lah. Right? Okay, I hope you understand that one. So now look at intersection. Intersection, the symbol is like a U-turn punya symbol. So a reverse N, sorry, reverse U, right? Imagine it. Okay, right? So intersection of two set S and T is a set that all elements that belong to both S and T. Means that we're going to take all the element that belong to both S and T. For example, let's say I bring the same example. S, we have 1, 2, 3, 4, 5, and 6, which is all possible outcome in rolling a one die. So let's say A, rolling die 2 times, we got 1 and 5. And B, rolling a die 3 times, let's say they got 1, 2, and 4, for example. So A intersect B means that we need to find element that have in A and belongs to B juga, right? So element yang sama is only one, right? Intersect. So A intersect B should be equal to 1, right? Okay. So now let's look at this example. Let's say A is equal to 1, 2, 3, 1, 3, and 5, and B is equal to 3, 4, 5, and 6, and C is equal to 2, 4, and 6, right? A union B, A intersect B. So A intersect B kita cari the same value, the same element. We have 3 dekat sini. We have 5, right? So itu saja yang sama. So A intersect B should be 3 and 5. But when you look at C, A intersect C, there are no same element A and C. So means that A intersect C should be null set. It should be empty set. Nothing, no element are same, right? So let's look at complement. Complement set of an event A is a set of all outcome from the sample space S. Complement set of event A is a set of all outcome from the sample space S which does not reside in A. Complement means some element that not in A but have in sample space. For example, let's say as we're rolling a die, 1, 2, 3, 4, 5, and 6. Right, let's say A, Ali toss a coin 3 times. So he got 1, 3, and 6. Right. So complement of A, right, complement of A, symbol for complement is either A prime or AC, right? We can use either one, but in my class we can use A prime, right? So A prime means A complement with the element of outcome in rolling a die which not reside in A. Maksudnya yang tak ada dalam A, tapi ada dalam sample space. Dalam sample space we have 2, 4, and 5, right? But these elements are not reside in A. So complement of A is 2, 4, and 5. Boleh faham? Very simple. We just do a review on set theory. I hope you already clear about set theory lah. So Venn diagram is a pictorial representation of set where set are represented by enclosed area in the plane. So let's say example yang I bawa tadi, we have sample space for rolling a die 1, 2, 3, 4, 5, and 6, right? Sample space means all possible outcome for one experiment. So our experiment is rolling a die. So 1, 2, 3, 4, 5, 6. So let's say A is equal to Ali roll a die 2 times. Right? Let's say 3 times lah. 1, 4, and 6. Right? So to draw a Venn diagram, so we just draw a big rectangle kat sini. So this one should be represent sample space. The rectangle should be represent sample space, which is all the possible outcome. And a circle represent A, which is 1, 4, and 6. Outside circle ni we call as A complement, which is element which is not in A but in sample space, right? So A union A complement should be equal to sample space. From this Venn diagram, we can conclude that when A plus A complement, it should equal to the sample space, right? Now, let's look at another term in set theory, which is mutually exclusive. Mutually exclusive, to describe this a situation where the occurrence of one event is not influenced or caused by another event, right? Where there is no intersection set between two set, which is set A intersect C is equal to null set. So let's say let's draw the set in a Venn diagram. Let's say we have a sample space. We have two set A and set B. So when these two set is have no intersection, so we can say that these two set are A and B are mutually exclusive. And A intersect B is equal to null set. For non-mutual exclusive event, mutual exclusive event is where we have two set A intersect B. We have the intersection between A and B. So A intersect B should be some value, right? So we can say that A and B are not mutually exclusive, right? Are not mutually exclusive event. Okay, boleh. We just do some review on set theory. So I hope you already learned this in previous subject in mathematics. We just review, and we will use this theory in to apply in introduction to probability, right? Right. But before we go further, let's look at the 5 law in set theory, law of algebra of set. The first law is we call as idempotent law. Idempotent law means that when A union A is equal to A intersect A is also equal to A. And when a set union with the same set, so it should be equal to the same set. Associative law means that when A intersect B and then intersect with C is also equal to A intersect B and C. Means that you nampak kat sini, the bracket ni kita boleh ubah saja. You can slide the bracket, right? Same goes to union, right? This is for associative law. Commutative law, when A intersect B is also equal to B intersect A. This is very important, right? So you need to remember this one. A union B is also equal to B union A. Right? Benda yang sama. It's not a metric algebra. It's just a set theory. Kalau matrix, A A multiplied with B is not equal to A dot B is not equal to B dot A, right? It's a different value for matrix, but for set it's just the same value. Distributive law, A union B intersect C, so it should be equal to A union B intersect with A union C, right? Same goes to A intersect B union C, so it should be A intersect B union A intersect C. Another law that you need to remember, which is a De Morgan law, right? So remember, I nampak dekat sini, I star two law that you need to remember, right? The first law, the De Morgan law says that when A union B complement is equal to A complement intersect B complement, right? A intersect B complement is equal to A complement union B complement. Right, so you should remember De Morgan law and commutative law. Right, others law is also is also important, but this is most important, 3 and 5. Okay, let's look at example number 3.28. Right, toss a pair of dice and then add the number facing up. Right, let E be is a sum of even, find E complement. This is very simple. So we have two pair of dice, so the sample space should be starting from 2, 3 until 12, right? Because the minimum value of die is 1 plus 1 is equal to 2, so 2 add up until the maximum number of dice, which is 6 plus 6 equal to 12. So this is the sample space for rolling 2 dice in one experiment, right? So the number of event sum is even, means that we need to take sum even, means 2, 4, 6, 8, 10, 12. So we've got the even number, right? And then E complement means that element that not in E but it has in sample space, right? That is a simple example for a set theory, right? So example number 3.29, 3.30, you can do it by yourself, right? Just read it, right? Now let's look at introduction to probability. Are you okay? Can we continue to introduction to probability? So I hope you're clear with set theory, right? Very simple set theory that we need to know. Okay. Yes. I record. Don't worry. So probability is a branch of mathematical studies of behavior of a random phenomena and deal with the combination of certain number or measure, right? So let's say we want to find the probability of E, probability of event E, probability of set E, right? So it denotes as probability of E. This is the symbol of probability. Some books will say it's PRE, right? So we will use this notation in our class. And the probability theory can be divided into 5 types, which is marginal probability, intersection probability, conditional probability, union, complement probability. We will learn all this in this subject, right? Now, let's look at the rule of probability. The rule of probability, that we have 3 rules of probability. The first rule is each probability must lie between 0 and 1, right? As we already learned in previous chapter, we know the relative frequency. The total of relative frequency should always equal to 1, right? Same goes to probability, because this is that one also a probability. And we should understand the probability, let's say probability of event X should be lies between 0 and 1, right? Probability can be either equal to 0, it can be equal to 0, it can be also equal to 1, right? So, and then the total of all probabilities, right, should be equal to 1. This is for a discrete, a random variable, and the integration from negative infinity to infinity of probability of X is also equal to 1. This is for continuous random variable. Later on next chapter we will look what is random variable, right? So next, the rule of probability. Let's say we have a lot of set A1, A2 until AN. It's a finite or infinite sequence of mutually exclusive event. So A union B, A1 union A2 until AN should be equal to probability of A1 plus A2 until AN. So this is the basic concept for a mutually exclusive event. The most important rule in probability is rule number 1 and rule number 2. Right? The total of all probability or the integration from negative infinity to infinity should be equal to 1. Right? This is from negative infinity to infinity. Alright. So theorem number 10, right, in this chapter, basically it's the same based on the rule of probability lah, right? Probability of empty set is equal to 0, means that there are no probability or event occur. Probability is self-dual, right? Same as complement set. So probability of A plus probability of A complement should be equal to 1, right? So because we already learned on previous topic, when we have A, and this is S, A complement, when A plus A complement should be equal to S, right? S means the total number of, the total element, right, in one experiment. So it should be always equal to 1, right? And then probability is increasing when the probability of A less than probability of B, means that A is also less than B. Right, this is a basic concept, and probability of A should lies between 0 and 1. Let's look at classical probability. So classical probability, basically we already learned in a previous topic, which is relative frequency, right? Relative frequency. So the formula for classical probability is defined as a probability of event A as the division of number of outcome in A and the total number of all possible outcome. Means that probability of A should be equal to number of element in A divided by number of element in sample space. Sample space, remember, previous topic we learned counting theory, right? So to find all the possible outcome, we need to use some counting rules, kan, to make your calculation faster. So number of sample space means that number of all possible outcome. Number of A, let's say we have sample space 1, 2, 3, 4, 5 and 6. This is for rolling a die. Let's say A, Abu roll a die twice, right? So dia dapat 1 and 4. So what is the probability of A? So number of A ada berapa? 2, right? Number in S is equal to 6, which is equal to 1 over 3. Right, 1 over 3 should be lies between 0 and 1. So 0.3, right? 0.33. So this is the probability of event A. Very simple, right? You just need to understand the basic concept, right? When you want to go for advanced concept, you need to really understand basic. If you don't understand basic, I don't think you can go for next topic, right? So let's look at example number 3.31. Okay, better we go for previous example yang I, I kata tak payah tengok tu mana ya. This is example yang kita tak payah tengok lagi kan. Alright. Remember example number this one. 3 letters are chosen at random and calculate the probability that at most 2 letters chosen are consonant. So we have the word altruism. So we already know this is the number of at most 2 letters are chosen consonant kan. Maksudnya paling banyak 2 consonant daripada 3 letter. Still remember last class? So what is the answer for this one? 5 choose 0 multiply with 3 choose 3 plus 5 choose 1. What is the answer for this one? Still remember? Ni example yang kita buat last week. Can somebody tell me? Hello? Last week kita dah buat kan? What is the answer saja? Oh, you tak buat? Yeah? 40? 46. Yep, 46. So let's say this is equal to 46. And this is what we call as number of two at most 2 consonant, right? So then in probability, remember the formula for probability. Let's say probability of A is equal to NA divided by NS. So we already know the number of at most 2 consonant to form 3 letter word, right? We need to find all possible outcome. So kita dah ada dekat sini, in how many ways can the cards be arranged? So this is ini tak betul lah. Ini dia nak berapa ni? Dia nak semua kan? Arrange semua balik. Let's say kita nak arrange 3 letter word juga. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 choose 3. So 8 choose 3, we will get berapa ni? 8 choose 3 is going to be 56, right? So 56 ni adalah number of all possible outcome to arrange 3 letter word from altruism. So to find the probability of at most 2 letter consonant, right? Consonant, it should be 46 over 56. This one should be equal to berapa? 46 over 56 should be equal to 0.82. Right? This is how we calculate the probability, right? Let's look back the question for exercise example number 3.31. So there are 8 Malaysian and 10 Indonesian, right, candidates to be interviewed by ABC Sdn Bhd, 6 available position, right? So here we have 8 Malaysian, 10 Indonesian. So the total should be equal to 18, and 18 we're going to choose only 6, right? So what is the probability of selecting 3 Indonesian candidates and 3 Malaysian candidates? So the first one, we want to find probability of selecting 3 Indonesian and 3 Malaysian. So we need to find the number of selecting 3 Indonesian and 3 Malaysian divide by all possible outcome. Right? I mean the combination of 18 and choose 6. Right? So 6 position lah. Right? Contoh. So to choose 3 Malaysian and 3 Indonesian means that we have Indonesia, we have 10 candidate. We want to choose 3 and multiply with we have 8 choose 3. 8 Malaysian choose 3 divide by all the possible outcome. We have 18 candidates. We're going to choose only 6 position. So this one should be equal to 0.36. So I hope you still remember counting rule, right? Right. So this is very important to fasten up your calculation, and even though when you write up programming, this is kind of simplest method to make your program short lah, right? So now example number 3.32. There are 4 autistic children and 5 hyperactive children at ABC Hospital. Right, find the probability that 4 children to be selected in a clinical study where 2 autistic children and 2 hyperactive children. So we want to find the probability of selecting 2 autistic children and 2 hyperactive children. So the formula should be 2A and 2H, the number of possible outcome for 2A and 2H, divided by number of all possible outcome. Right. So we have 4 autistics, 4A and 5H. It is sum up to 9. We want to choose how many? 2 and 2 means that 4. We want to select 4 out of 9. And remember, this is all distinct object, and we want to take 4 out of 9 means that taking R out of N. So this is a combination rule. So when you want to do a combination rule, so easy to remember, try to solve for denominator first. Denominator we have 9, choose 4. Very easy, right? For nominator, 2A and 2H. So we have 4 autistics. We want to choose 2, multiply with, and 5 hyperactive. We want to choose 2. So this is how we solve the problem. So this one should be equal to how much? 0.48. Right? And at least one hyperactive children to be selected at clinical studies. So one hyperactive maksudnya at least one, maksudnya sekurang-kurangnya satu, means one hyperactive, 3 autism, or 2 hyperactive, 2 autism, or this is 3 hyperactive, 1 autism, or 4 hyperactive, 0 autism. Right? So you need to find this number, divide by 9 choose 4, you will get the probability of at least one hyperactive. Right? So in this one, this is a naive way lah. If you don't know how to do interpolation, you can do this one. Or if you want to do this one, how I get 1 minus this one? Means that, so let's say we draw a Venn diagram. We already learned Venn diagram, right? So, and a complement set. So let's say all possible outcome. right? So let's say this is at least one hyperactive, right? One hyperactive, right? And outside here, dekat sini, senang macam ni lah. Susah nak ingat macam ni. Let's say, okay. Let's say dekat sini, 0 hyperactive and 4 autism. Right? And then, dekat luar ni adalah, sekurang-kurangnya mesti ada satu hyperactive lah. Right? So, to get this value, what you need to do is, the sample space should minus the 0H4A. The sample space, probability of sample space is equal to 1. The probability of 0 hyperactive, for autism should be equal to 5 choose 0 multiply with 4 choose 4 divide by 9 choose 4. So this one should be berapa? 0.01, right? I think. So to find the probability at least 1, so means that S minus this one lah. So 1 minus 0.01, it should be 0.099. Okay. And let's look at another example before we go for relative frequency, right? So my target is we want to finish up until relative frequency, and for this is 3.5.4 ni kita continue next class, right? So example number 3.3, there are 4 candidates from TAPA, 5 candidates from Parade, and 6 candidates from IPO for in a job interview for at the Bootstrap Resources. They have been summoned for interview for 3 available positions at Decision Science Department. So find the probability that 2 candidates from IPO succeed for that position. So we have 4 from TAPA, 5 from Parade, and 6 from IPO. The total should be equal to 15. And out of 15, we want to select only 3, right? By using the rule of counting, right? Yang kita belajar, does order matter? Order does not matter, right? So when order does not matter, we can use combination. And when order does matter, we use permutation. So this one, if you want to find we want to find number of sample space, it should be 15 choose 3, right? So now for the first question, right, let's say this one. So we want to find probability of 2 candidates from IPO and 1 candidate others. We don't care whether it's from TAPA or Parade, right? So this one should be equal to number of 2 candidates from IPO and 1 from others, and divide by number of sample space, right? So it's easier to start with the denominator, 15 choose 3. Always start with the denominator lah, so we know what is our limit. And for this one, 2 from IPO means 6 choose 2, means 6 dekat IPO kan, choose 2, multiply with 1 from others we have 9 choose 1, right? So this one should be 0.2967, right? So now B, one of each district candidate has succeeded the interview, means that we have three district, we have three position. So one from Ipoh and one from Tapa and one from Parit. So probability of finding one each, right? So this one always start with the denominator. 15 choose 3. Denominator means that all the possible outcome, and this one should be 4 choose 1 multiply with 5 choose 1 multiply with 6 choose 1. This is going to be very easy. Okay, and we will get the answer 0.2637, right? So all three candidates from same district had succeed the interview. So maksudnya in this case, let's say either Ipoh got all, 3 from Ipoh, 0 others, or 3 from Tapa, 0 others, or 3 from Parit, 0 others. This is what we want to find, the probability of this one. So always start with the denominator, 15 choose 3, right? When Ipoh succeed, Ipoh we have 4 candidates. Right, is it 4 candidates from Ipoh? Yes. Ipoh is 6 candidates from Ipoh. So 6 candidates from Ipoh succeed and none from others. None is 6 and we have 9 lah. 9 choose 0. Right? Plus 3 from Tapa. Tapa we have 4 candidates. 4 choose 3 multiply with berapa? Yang lain ada 11. Parit and Ipoh, 5 plus 6 is equal to 11. 11 choose 0. Right? And kita turun bawah sikit malas nak pergi sana. Okay. So plus from Parit. Parit we have 5. 5 choose 3 multiply with, the balance is 4 and 6 equal to 10. 10 choose 0. So I really insist you to write like this, because if you don't write like this, you don't understand the concept, right? Even though there is some shortcut lah, because 9 choose 0 is always equal to 1, right? So you will get 0.0747, right? Remember, don't do shortcut unless you're really terror, right? Dah master this topic, you will get you dah dapat A dalam test, so then you can do a shortcut lah. So if you don't get A in test 1 and test 2, jangan buat shortcut, just do whatever I do, right? So now let's look at relative frequency concept of probability. So relative frequency, as we already learned in previous topic, right? Chapter number 2, yes, right? In frequency table, we can calculate a frequency, relative frequency. So probability of an event happening is determined by observing what fraction of the time that similar happened in the past. If the experiment can result in any one of n different or equally likely outcome, and if exactly n of these outcome respond to A, the relative frequency is number of time event occur in the past, which is the frequency, right? Ataupun kita letak frequency divided by the total frequency. Right, this is another expression. It's also equal to NA divided by NS. It's the same concept. So konsep probability takkan berubah lah. It's the same. Kalau you pusing mana pun, dia sama juga. Just kalau you baca different books, maybe you will get a different notation lah. Right? Different notation doesn't mean it's a different definition. It's just a same definition, just trying to make an interesting dalam penulisan lah. Maybe dia nak tukar lain sikit ke, nak bagi you pening ke, seperti dia lah. Right, so this is a proof. I don't want to go for a proof. And like look at the example number 3.34. This is a frequency table, right? Mana dia hilang dia punya garisan-garisan ni pun I tak tahu. Tiba-tiba hilang garisan. Right. Baru nampak frequency table. Okay. So this is a frequency value and this is a relative frequency. And this is your class. Right. We have a number of abundant call. 0, 1, 2, 3 and more than 3. So number of call ni maksudnya there are no abandoned call. Maksudnya 120 call has been abandoned. 80 calls dua kali. Right. Okay. So now find the probability no call has been abandoned. So no call has been abandoned means that so 0 lah, probability of x equal to 0, right? So this one 1700 divided by the total value, which is 2000, right? It should be very simple, right? 0.85. Remember the concept is probability of A equal to NA over NS. You need to understand the concept. Number in A divided by total possible outcome or total number. Itu saja. That is the main thing that you need to understand lah. Right. There are 2 or 3 calls have been abandoned, means a probability of 2 or 3. 2 or 3 calls have been abandoned means that true or probability of 2 plus probability of 3 means equal to probability of 2 is 120 divided by 2000 plus 2 is 80, right? 80, right? Tengok betul-betul sini. And 3 is 40 over 2000. So this one should be 0.06. Okay? Simple, right? Simple. So let's look at another example, which is example number 3.35. Right. Since this is very simple, it's just a basic concept, right? So for today's lectures, I just want you to understand this concept, because the topic that I teach today is very basic. So the question for final exam will not touch on this topic, but you need this knowledge to understand the next topic, right? So if you don't understand the current topic, then you will not understand the next topic. You will not able to do at all, right? So you need to understand this topic very careful. This is a basic, right? So soalan-soalan final exam tak tanya macam ni lah, ha? Soalan tanya final exam ni you boleh belanja air pizza sebab soalan senang keluar, tapi soalan ni tak keluar, right? Don't worry. So you need to understand basic concept lah. Okay, the table summarize the result of all the driving tests taken at the Bootstrap Test Center during first week of June 2016. Right. So I kena keluar buku baru dah. 2016, now 2021, 5 years already. So this is a contingency table, right? Contingency table, kalau you nampak ni, dia punya table dia hilang pergi mana tak tahu, right? A person is chosen at random from those who took the test in that week, find the probability that person passed the driving test. So what is the number of person pass driving test? So we want to find probability of pass. So we need to find number who pass driving test divided by total number of people who took the driving test. So number of pass driving test is 75 divided by 100, which is number of people who took driving test. So this one should be equal to 0.75. Right? So now let's look at B. Was female who failed their driving test. Means that probability of female. Okay. Macam ni dia punya. Okay. Female who fail driving test. And this is female. Macam mana nak letak? This is, let's say kita letak this is male, kita letak sebagai lelaki, and this is perempuan. This is pass and fail. Kalau tidak nanti dia punya simbol sama. Susah, confuse. Right? Okay. Sama juga. Ayoyo. This is wanita, W. Okay, good. Male is wanita dan lelaki lah, cukup lah. Kan? Okay, female, okay, W, right? And fail their driving test. Fail her driving test. Fail means F. Fail means that probability of W intersect F. So this one should be female yang fail. So it should be 15, right? So 15 divided by number of people who took driving test equal to 100 is 0.15. Right. So C, a male is chosen. What is the probability that he did not pass the test? So probability of male, lelaki chosen, and did not pass driving test. You know, pass means fail. So same concept, male fail is equal to 10 over 100 equal to 0.10. Okay. Now let's look at example number 3.36. Do we have? This is going to be last example in the books. Nanti kita tengok example from your final exam. Right. Pukul 10 dah. Right. Kita nak habiskan cepat. So a car manufacturer carry out a survey in which people are asked which factor from the following list influence them most when buying cars. So we have A, B, C, D, E. A means the color range, service cost, driver airbag, fuel economy, and range of optional extra. This is the pie chart showing result of 90 people. The name of those who apa dia kata lagi? Find the probability that someone said driver airbag will win the prize. Driver airbag kat mana? Driver airbag is C, right? C is equal to this one. This one is quite challenging lah. You tengok kat bawah ni macam mana I buat. The total circle, right? In the circle we have 360 degree, right? So kita tambah semua ni, right? So semua ni ada berapa? 128 plus 60 plus 21 plus 96. This one should be equal to berapa tadi tu? 300, 305. Right? Contohlah kan. 305. So C should be equal to berapa? 360 minus 305 should be equal to 50, 55. This is a 55 degree, right? Okay. Um, okay. Alright. So macam mana dapat 55 degree ni? Remember kita buat pie chart macam mana? How we construct pie chart? We construct a pie chart 360 equal to 55. This is 90. We want to find X. Right. This is how we got the degree for C. Remember? Can. So how to solve this one? Bawa lapisan habis ni kan? Can you solve again? Can you calculate for me? What is the value of X? What is the value of X? $13.75, right? So I think jawapan bawah tu tak betul lah. So kita nak tahu what is the probability who will win. Someone says driver airbag means that 13.75 divided by 90 should be 0.1527. So basically it's the same answer kan. Lebih kurang sama lah. This is another way to calculate lah. Right? Okay? Let's look at example dalam final exam question. Tak ada soalan ni. Soalan 3, soalan 2. Determine value M, expected numbers. Ni belum belajar lagi. Okay. This one, question number 2, kita dah buat kan? Right. This is June 2016. Right. In how many words can be formed with the letter of electrics if the all vowel occupy at least at the last 3 place? Vowel. Alright. Kita tengok question 2. This one. Okay. Oh, besarnya. Alright. So June 2016, I think. Yep. June 2016, how many words can be formed with the letter word electric if the vowel occupy last three place. So vowel kita ada berapa? 1, 2, 3, 4. Right? And all object dekat sini kita ada 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8. So we want to when n equal to 8, and then kita nak dia duduk dekat belakang tiga vowel tu, e and I duduk dekat belakang. Yang depan ni ada L, C, T, R, C. Okay. E, E, I. So how to do this? Remember yang saya cakap dulu macam mana nak buat? We need to tie this together. Betul ke? So we have two places here, right? The first one and the second one, right? The first one we have 1, 2, 3, 4, 5. So 5 factorial divided by 2 factorial. Multiply with 3 factorial divided by 2 factorial. Right? That's one very simple. Okay? Remember, theorem number 1, kita ada first is one place n step. First step kita ada n object. Second step we have the second object. So kita menggunakan theorem number 1. Setiap theorem ni, setiap satu first place ni kita letak all the consonants kan. So consonant 5 factorial divided by 2 factorial. And then for vowel, kita letak 3 factorial divided by 2 factorial. So we will get the answer lah. So now, the table below shows the information about 200 children in the kindergarten group according to gender and whether they wear spectacles or not. A student is selected at random. So now, let's look at total. Always put total lah, senang you nak nampak. Total. This is also have total. When you have a contingency table, always put total. Right. So this one kita ada 200 children. Right. So 24 plus 90 is equal to 24 plus 90 should be 114, and minus 200 should be equal to 86. Right, and this one should be 156, and this one should be 44. Right, so now find the probability of A union B. Where is A? So this is A, this is B. Probability of A plus probability of B. Basically this one you not learn yet lah, but since kita dah touch sedikit, then it's okay. Probability of A intersect B. So this is the formula. Basically kita akan tengok dekat bawah ni lah, subjective, this one, the law of probability. Don't worry. So kita touch sedikit, right? So probability of A is equal to berapa? What is A? 114 divided by 200. 114 divided by 200. And probability of B is 44 over 200. And probability A intersect B, A intersect B is A dekat sini, A dekat sini, B dekat sini. So 24, right? Dekat sini kan. So 24 over 200. So we will get the answer lah. Okay. Just a snippet before we enter the law of probability dalam next class. Right. So for this class, I just want you to focus some basic notation and how to calculate probability from using counting rules and set theory. Right. That is very important. Just try to understand and refresh this knowledge on the next chapter. Right. Ada soalan before we end our session? So if you don't have question, then I think that's all. Don't forget to sign in your attendance. Right. Attendance is purely your responsible. If you forgot to sign in your attendance, means you will not met 80% of the attendance requirement lah. Right. So you need to understand the consequences of not meeting 80% of the attendance. Okay. I think that's all. Thank you very much. Assalamualaikum.